Take a look at a few more examples of integrals with ease. So let's take a look at this one. Now, sometimes with u-substitution, we have to get creative with how we pick our u's. So remember, we said that u's could be substituted maybe for exponents. If you did that here, you don't make any progress. One of the other strategies, you could do algebraic manipulations. There's not really any good ones here. So instead, another good choice is we said we could let the denominator be u. So let's try that. So if we're going to let u be equal to 1 plus e to the x, then du is equal to e to the x dx. So my denominator was 1 plus e to the x, that's u. The numerator is e to the x times dx, that's perfect. So this was a great choice of u-substitution. Now, because we have bounds, remember, we want to plug in our bounds and figure out what those are in terms of u's, because these are really x values. So we have when x is equal to 0, u is going to be 1 plus e to the 0. E to the 0 is going to be equal to 1, so this is 2. And then when x is equal to 1, we have u is equal to 1 plus e to the 1, and that's just simply 1 plus e. So what this integral now becomes is the integral from 2 to 1 plus e, and I have a 1 over u du. Now to integrate this, remember 1 over u du, that's and when you integrate that, that is natural log of the absolute value of u. So this is natural log of the absolute value of u evaluated from 2 to 1 plus e. So now I plug things in. So I plug in my top number first, natural log of the absolute value of 1 plus e minus the natural log of the absolute value of 2, but both of these numbers are positive. They're both positive, so it doesn't matter that you have absolute values. So this is really natural log of 1 plus e minus natural log of 2. And that's the answer. You can't simplify. I mean, you could simplify by using the subtraction rule and dividing over, but that doesn't really simplify anything. So this is your answer, natural log of 1 plus e minus natural log of 2. This one up here, try to do some u-substitution again, because basically u-substitution is your go-to thing if you can't immediately pick out the antiderivative. So this, a lot of choices of what we want to do, but this is one of the tricks where, notice if you look at the relationship between the numerator and the denominator, you take the derivative of the denominator, you get the numerator. So we're going to use that. So we have let u be equal to e to the x plus e to the negative x. Then du is going to be e to the x minus e to the negative x dx. E to the x minus e to the negative x dx, that's our numerator. That's great. So this now becomes the integral of 1 over u du, which is natural log of the absolute value of u plus c. And this is natural log of the absolute value of e to the x plus e to the negative x plus c. And there we go. That's your antiderivative. Now, what if we start to throw in some tricky ones? Like, what is the antiderivative of x to the e? Now, so when e is in the exponent, what does this mean? This means x is now being raised to some constant. What is our rule for when x is raised to a constant? We know we add 1 to the power, then divide by that power. So that's exactly what we're going to do here. I'm going to add 1 to the power. So I have x to the e plus 1, and I divide by that power. And there we go. Basically, nothing more than just treating this as a constant. This could be 7, and it would be the same thing. This could be pi, and it would be the same thing. Obviously, except for -1. And then this last one, what about just e by itself? So if there's no x's present, this is the integral of a constant. The rule for integrating a constant is just an x appears, and that's it. So I have e times x plus c. So just treat e as a constant unless specifically it is the base of some exponent with x. Then it has these nice special properties. So there we go. Again, just a few more examples, making sure we don't confuse ourselves, remembering some things about our definite integrals, our u-substitutions, and some things that just require us to be comfortable with symbols really just representing constants.